Let's start up by looking at the graphs of log functions with different values of the base. Okay, so in general, if you look at the first one here, this one, this is y equals to log base 2 of x. Now, as you increase the base from a equals to 2 to 3, okay, it actually goes down a little bit, and this one goes to the left a little bit, and so on. It becomes less steeper. If your base is between 0 and 1, it will look like this. When I go from base a equals to 2 and becomes base equals to 1 over 2, this is actually symmetric of each other. Likewise, if I go from 1 over 2 to 1 over 3, it will become less steeper. And this one is actually symmetric to this with respect to the x-axis. So this is something that we must remember. And the other thing you need to know is your x-intercept is always 1 regardless of the base. But on the other hand, there's no y-intercept. It will only go infinitely close to the y-axis, but it never touches. Now let's move on to an example here. So this graph is y equals to log base 2.5 of x. And we want to use this graph to find the value of this. Okay, so the same base, and we want to find when x equals to 3 what is y. And so we draw up a line from x equals to 3 up here, and we find the y. And so the answer will be 1.2, correct to 1 dp. Now likewise, when x equals to 0.3, we go here, x equals to 0.3, and draw this line here, and the corresponding y would be negative 1.3, correct to 1 dp. Now for part 3, note that the base on the graph and the base that we wanted are actually different. So how do you put them together and not use calculator? Well, here's the trick. Okay, log base a of b. Actually, we can make this into a fraction of 2 logs as long as they share the same base. And we could actually pick any base. And in this case, because the graph that we have has base 2.5, then we must use 2.5. Then we could actually go to x equals to 1 over 4, here, somewhere here, and x equals to 2 over 5, somewhere here, to get the corresponding y's. Now, if you notice that the values of these two numbers are actually a little small, and for this portion of the graph, the curve is a little too steep, and in this case, a small misreading on the value of x may result in a huge misreading in the values of y. So we want bigger values to improve the accuracy. So what do? We rewrite it as this, and we write this into this form. Why do we do that? Because now we could move the negative 1 to the front, which will cancel out later on. And these two numbers are much bigger. But we know that log base 2.5 of 2.5 is actually 1. So we just look at this part. When x equals to 4, log base 2.5 of 4 is 1.5. So the answer is 1.5, correct to 1 dp. Now for part B, this is the other way around. Okay, it's asking, using this graph, when the y value equals to 1.4, what is x? So from the graph, when y equals to 1.4, this is the reverse of part A. So we start out with here, the horizontal, and then the vertical. And so the corresponding x would be 3.6. Now for part 2, again, the base are different here. And our goal is to convert this to have this thing somewhat. So first of all, if this is x to the power of 1 over 2, so we move here to the front. Then using what we've just learned, we can rewrite this into here, and we pick 2.5 to be the base. And then I move the 2 to the other side to get 1.8. And again, just like last time, I flip this around. And so I have a negative in the front. But because this actually equals to 1, then I will end up having this whole thing equals to negative 1.8. Then we're almost done because we have successfully converted this into this here. So now we could draw the graph when y equals to negative 1.8. Draw this back up here. And the x value would be 0.2.